Okay, we've got our next presenter coming up here. This is going to be Alejandro Rios Peña from Livevox. He's going to be talking about curated cloud design patterns for Opensips-based platforms.
Thank you very much.
Microphone off?
Yes.
Put it in a nipple.
That's fine. Just turn the body.
Good. Can you hear me? Yeah.
Ladies, quiet down now.
Right. All set? Okay, thank you. So hi everyone. Thank you for having me. I'm Alejandro Rios, and I'm going to talk to you about cloud patterns for.
Just pull it higher up.
Yeah, I'm gonna take it in my hands. So the idea of this talk began last year when I was in GlueCon in Chicago, and I saw that there's a lot of challenges that keep repeating, and everyone coming to this conference start sharing the same. So we have the talk by Jonas from Tulio this morning, and other talks talking about different challenges that we currently have, and the solution then start coming familiar again and again. So we also had a couple of stories to tell, and I like a lot putting together all those best practices, like and documenting them and sharing them as part of giving back some to all these great open source projects that we use. So first, see how why we started talking about this. Then our main challenges. Then 5 principles that we always follow. And finally, a glance or demo of 12 patterns that I encounter on these best practices. So first, quickly, Livevox, founded 2000. Sorry, we are mainly call center in the cloud. So that's a special scenario, and I'll show you in a moment. We have about 200 call center clients, and most of them have more than 500 agents. We are like about 400 plus employees. We have 4 offices. I'm from the Medellin office in Colombia. So it's mainly about customers in the finance industry. So it's very highly regulated industry. We'll see about that in a moment. So it's mostly outbound traffic that we handle, and we handle about 9 billion interactions, calls, attempts per year. And most of those calls don't really get connected. So that's also part of why we are focused on best practices for attempting to connect those calls. There's a lot of consumers using that. And it was all very happy story and evolving this platform until Friday, November 2nd, 2012, 9 a.m. We got the call from our data center provider in New York, and they said, hey, it's been a whole week that Hurricane Sandy has been hitting New York, one of the deadliest, most destructive storms of the seasons. And hey, we're gonna shut down the data center in a couple of hours, so see what you can do. And we obviously had high availability clusters, and we usually have some backup plans and a second data center at that time. And we try to make everything work as seamlessly as possible, but it took us about until midnight until we could put together the platform back in shape again. So that was like a call for us to reshape a whole disaster recovery strategies. And most of us have these kind of challenges or will. So those main challenges in these kind of platforms are both reliability, also flexibility, scalability, and security is also a huge pain for us because most of our hosts are TLS and have very strong security requirements. So how do we manage to get through all of this? The first thing that we did was saying goodbye to our old hot standby clusters. That didn't work so well. The failover was too complex, and we decided to simplify the whole platform and use strictly active redundancies. So we just started using a lot of horizontal escalation. And we adopted 5 principles that we try to implement on our different layers. I'll go through each of them. So the first one is cattle-driven. And this is a concept by Randy Baez from Elastic Cloud. And he talks about pets versus cattle. So we used to have, by the time of the storm, a couple of outbound proxies that were like our high availability clusters. And we also had a name for them because they were so special. We tried to keep them uptime for years. And when that data center fell down, we had to stop forgetting about those servers as something that we had to take a lot of care of. And instead, we started treating servers as cattle. So something that we can just terminate, or once it's put together in production, if it fails, we just throw it away and put a replacement. And that took a lot of steps to be done. One of the big steps that we had to do was avoid repeating ourselves. So don't repeat ourselves is another principle we follow, also known as duplication is evil. Also a concept we brought from Andy Hunt and Dave Thomas. And this is a simple idea, but very hard to implement because you start getting the same code and repeat it, and it's easy to repeat. But then when you have not just a couple of proxies, but we currently have like over 100 Opensips servers instances. So when you want to make changes and redeploy and make adjustments or anything in every new version, it's going to be very complicated. You have duplicated code or configuration. Another is service oriented. Also, we used to have like this huge 3,000 lines Opensips script for our outbound proxy. And instead, we started to split it in a lot of things, in a lot of different parts. We also did the same with media servers. So we have just inbound, just outbound, just agent media servers, and very functional specific components. And then we compose them and have interfaces clearly defined so that we can reuse them. Finally, something that also looks very simple, but when you are in trouble, then you say, okay, I should have done this, is treating configuration as code. So we don't have any configuration that has to be done on the machines like by hand or by demand. Everything is on a separate version system, and all the infrastructure, scripting, and pieces are also treated like code, versioned, etc. And we also have 3 different categories for configuration. System configuration, like environment, setting up the boxes, static, like IP addresses, host names, etc. for each component, and dynamic, like all the rules and the data that each component needs. So we take all that as code. Finally, the other principle we have is continuous integration, and putting this together is also takes a lot of time, because you need to make sure that you can do it frequently and that each component can integrate again and again and again, even on a daily basis or several times a day. And it has to be really, really simple to deploy, so that every time there's a more change, it can also trigger automatically, and that way everyone knows that what he changed is not going to break the whole platform for the rest of the team. So those are all these practices. I've also put them together on. I'm putting them on. Here, yes. So as part of sharing this, I also started a small wiki on GitHub that I will share the link again at the end. Just wanted to make sure that well, there's a lot of text in these slides, but everything's going to be online available later. I want to jump in straight to some demos. So let me show you how we've done this. So these patterns that are on that wiki all try to implement these 5 principles, and it's generalized way to solve different problems. So a design pattern is something that is reusable. It's not supposed to be vendor specific. You're supposed to implement it with any technology, but to be honest, what I put together for this first version was very Opensips specific, and also very specific to our own use case of call center call, which is, I think, different from many other use cases that you could have, because in call centers we have like a small set of agents trying to reach or place a lot of calls, both inbound or receive a lot of calls inbound. So it's not like one-to-one connection, it's like a few to a lot type of connection. So it's kind of a different scenario. And each pattern has well, the problem solves, how you can solve it, and some examples. Also, it's worth mentioning, we are the same as with open source happens with design patterns. So it's something that you build upon some other patterns that other people is using for other things. So we also borrowed a lot of patterns from Azure and AWS and others. So let me show you some patterns, and then actually let's jump straight to Sunday. So in this demo, I'll show you a little bit of how we manage, how we handle builds. So there's a lot of commercial tools to doing this, like for example Bamboo. We also use it for a while, but then we came up using our own tool and explain why in a minute. So we have a single place where we have all the components and platforms, about 28 components. And we have a single place where we know exactly what versions and what components and what instances of the servers we have. Here we are deploying an Opensips server that is functioning as a register for agents. And we also can tell what environment we're going to deploy this component to. And one thing that I want to show you once it's deployed, it's the pattern we are using here is called configuration cycle. So first we bootstrap the instance, and then we have the configuration of Opensips packaged as an other RPM. So we do deploy and pull, like a standard deployment of the Opensips RPM. But with our configuration is kept under its own version, and it's also being self-registered to a central place. So there we saw 3 different patterns. First, the bootstrapping pattern. That's how you can quickly create instances and start them and put in them. and how do they pull the initial data from the environment. So we use Puppet for that. There's other alternatives, but Puppet is we have some recipes, and you can use this kind of bootstrapping system or CloudFormation or some other that are built for specific cloud providers, where you can tell like the basic system data that each instance needs. The other pattern that we saw was the configuration sidekick. As I explained, what is packaging custom scripts as a separate RPM. So this allows us also to have the OpenShift script seen as pure code, and we also maintain like our own library of snippets of OpenShift scripts that we put together. So we have different type of OpenShift servers. So for example, for Outbound, we put together a script based on those snippets. For Inbound another, for Agent another, etc. And it's all done in a package script way. So you have to put a lot of automation in this kind of builds when you want have a lot of servers. And the other pattern that we saw on that small demo was a component manager. So you also want to have all your central servers service for provisioning and managing all of your component installations in a single way that you can track. Okay, so let's on to the next one. The other pattern is very easy. I mean, it's the kind of thing that most people using OpenShift already know, but when you step back and try to abstract it, you find interesting things. So, for pool management, oh, wait. Okay. So for pool management, we have our own another interface. And when the components are deployed, they are ready to be added to separate pools. So we have TLS, UDP pools, and we can program the OpenShift modules here. But it's a single place that we use to provision the pools for all our OpenShift, and it's a standard way. So this it's also something that most people using OpenShift should be doing. But what's interesting there is that when you think of it as a pattern, then load balancing makes sense, because in call centers you have a lot of interactions, and the more complexity and the more high volume you have, the less complex you want the failover to be. So when you have many calls coming to a place, or many call attempts, trying to make a single server to be available the whole time, it's harder than having a whole group of servers handling just a pure load. And if one of them crashes, you could just replace it for a new one. So OpenShift has a couple of very good modules to do it, the dispatcher and the load balance module. And one of the important things is that you do prove the health of the members, like in an intelligent way. It's not just like testing that the component is up, but that is processing what it's supposed to process. We'll go a little bit further into that in a minute. And something also similar to what others have already said, sometimes making the failover too automatic or too immediate, it's not a very good practice. So sometimes it's better like to automate a lot of the monitoring and automate the entering and taking in and out members out of the pool, but making that decision like a conscious or human verified decision at the end. The other pattern we are applying there is the scale out. So also sometimes we like to, struggle a little bit trying to make a lot of calls into a single server. but sometimes that also is not a good idea for a lot of scenarios. So instead of that, we try to do a lot of benchmarking and planning, so we know exactly how many calls can each instance type process. We use like t-shirt sites that we can use across different cloud vendors. So we know that this size of virtual server in AWS compares to this other in Google Cloud, and we can more or less know plan in advance the capacity management. So we know, for example, also by monitoring and benchmarking our own traffic, we know that sometimes in the middle of the week the traffic will increase, and in the weekends it will decrease, so we can turn off our own instances in the cloud and manage cost expense by doing that. The other pattern we use here is domain sharing. So I showed you that we have different pools. We have separate pools for UDP, separate pools for TLS traffic, which uses some more specific media servers with security. And we also have a separate pool for WebRTC, which is using the Opus codec. So we try to split pools specific to what they are doing, even though they are using the same code base sometimes. Finally, one of the ones that I like the most, and it's been very, very helpful, is doing transition migrations. So by doing making sure that every layer in the platform is pooled, you can you don't have to worry about upgrading an instance or making adjustments. You can or like having windows, maintenance windows, because you can just start lowering the weight in that instance until it's almost zero, and then you take it out of the pool. Or if you have a new instance or a new version, you will put it into the pool with a very low weight, see how it works, monitor, and increase the weight, increase gradually until the old version is out and the new version is into the pool with full weight. So that's very operational, but very useful. Let's see, I have some final demo here. We're doing time. Another one I want to share with you. It's on dynamic rules. So again, we used to have this huge Opensips script, and it was very hard to maintain, and adding new stuff there was very painful. And there are some modules in Opensips that implement cache or patterns that you can use, and you can put some your dynamic rules into the database and then reload the Opensips. That's very useful. But we had some very specific cases where those modules didn't implemented what we needed. So we implemented our own cache using the cache readies module, and this could, I think, be generalized in that you should strive for and have a small Opensips configuration, hard-coded, and try to make everything else dynamic and very, very lightweight. So here's an example. We have like our own interface, and we can put like the conditions and routing rules here and push them using the cache module into Opensips. So this takes a lot of time, and it's also useful for making a test of new pools and new members of the pool, that kind of thing. So again, the other nice thing about this is that, and the reason why I'm not showing like the actual code is because the main takeaway is ideas that you can take and implement your own way. So this is just one example, but at the end, anyone can implement their own way of doing it, cache and keeping configuration small. So finally, this implements the cache dataset. There are different things that you have to take into account. The main thing is when you do the cache, we like a lot to push the data instead of pulling the data. So our process never access the database directly. We always use the memory copy, and we have a separate process that pushes the data into the memory copy. And also what we do is we use like an index in the Redis that the Opensips will know. If we are pulling like a huge set of records, we put an index to that, and Opensips is always checking for that index, and we read from the dataset. And when we update the dataset, we first start updating the dataset. That will take some time while the data updates, and the last step is updating the index, so that Opensips will always have the latest copy of the memory data in the cache. Those are the dynamic rules. Again, all this is on the GitHub link. And the final demo I wanted to show you is again an automation. So we are very we remark a lot into automation because that's been what's most useful managing all this. So here's an example using a Ready API for WebRTC. Stop there for a minute. So we have a JS zip library using here, and this is just a page that is opened using the Ready API to test the WebRTC. And all this automation makes sure that every new instance is tested before going out to production. Okay, so one other thing you have to take into account when doing these automated tests is that every test is like unique, and you have test cases for each thing. So we are testing here WebRTC connections, and we will also test the client. Also wanted to show here the pattern that we share with some other presenters here, is that it's critical that you control the client that's connected to the platform. So we have our own set of clients and a small set of clients that we allow into the platform, so that we can really deliver them all that reliability and pool management. Otherwise, it will be very hard to admit any kind of zip client. So this is our own zip client that is auto-provisioned by us, and we integrate all that into the agent experience. Right, so in terms of result there, let's call it authentication delegation. So that's also something we see a lot into call center platforms, that the relying on the zip authentication is not a very good practice. You know, even with TLS and secure RTP, the zip authentication is just untrusted. So instead of that, you have to make sure the application layer is the one that is making the authentication, and the voice layer to keep it as simpler. And if someone gets access, for example, I can connect as an agent, making actual calls or things that are actually billable, it's a completely separate system. So even if one of the systems gets compromised, you won't get charged, because it's everything isolated, and just on the application layer is where everything connects. So you have the agent leg coming on one side, and you make the outbound calls on another leg, and then the application is the one that creates a conference to bridge them. And also, well, we heard a lot about Anycast, and we are very excited about all the Opensips clustering capabilities. But we also like taking control of the clients, because at the end, the clients is the ones that are trying to connect. So we try to delegate a lot of the disaster recovery or connection into the client. So that we use DNS SRV, and we know that we support it because the client is controlled by us. We also, for WebRTC, we also ship a desktop application, so that we make sure that that one hits the proper environment. And finally, well, I'll show you the test that has to be. Let me show you that as well. One thing I didn't show here is once the deployment is done, and we have the component deployed, we finally have some, well, some of you already know the zip load tester. So we make sure after we deploy the component, we run a series of ZP scenarios, and it's all scripted and it's running again every time a component is deployed. So we make sure that once it's deployed, it's processing. And this is also used by monitoring tools, so that it's not only like responding to a zip options or a zip ping, but it's actually making registrations, actually making the call being routed. Putting all that together, we managed to be prepared for the next hurricane season. That's all. So there's the link for the patterns. I hope for next time I can also include some actual Opensips code snippets on that wiki. So my idea is to start growing it and put actual examples of Opensips code in there. So thank you very much.
Okay, thank you, Alejandro. Do you have any questions? Questions out there? Anyone? Okay.